Lesson 24, Fractional Equations and Overlapping Triangles. Example 1, solve this fractional equation. So let's think back to when we first learned about equations, and we learned that we're allowed to multiply both sides of the equation by the same non-zero number, and that preserves equality. So if I multiply, and I'm just going to use a general number symbol just to represent, it could be any number as long as it's the same. And then what will we do? Well, we distribute the multiplication to every single term. Okay, so times every single term on the left and the right. So we're going to use that idea in order to get rid of our fractions here. Okay, we want to get rid of the denominators. So our strategy is going to be, we're going to multiply both sides by the least common multiple of the denominators. So let's erase all this scratch work here. And I want you to think of what the least common multiple is of the denominators. Okay, so we have 4 times 3. What's the smallest number that 4 and 3 go into? That would be 12. By the way, this is also called the least common denominator, the LCD. Okay, so we're just talking about the least common multiple of the denominators. And so what we're going to do is we're going to multiply every single numerator by the same number, which is that LCD. And why do we want to do that? Well, we want our denominators to go away. So we want every denominator to be a factor in the LCM so that we have cancellation. So we see in that first term, the 4 goes into the 12 3 times. Second term, the 3 in the denominator goes into the 12 4 times. And on the right side, the 4 in the denominator goes into the LCM 3 times. So we have cancellation. Well, what happened to all our denominators? They are now gone. So they're gone. So our next step is going to be to multiply what remains to each numerator. We want to be careful when we multiply, however. If we have more than one term in each numerator, we need to think of this as a group in parentheses. All right, so let's go. 3 times 2x for 6x and 3 times 3 for 9. Okay, minus stays the same in the middle. And our next term here, we have 4 times 4 for 16 equals, drop that down, and then we have 3 times 1 for 3. On the left side, let's gather our like terms. For 6x minus 7 equals 3. Let's add 7 to both sides. We have 6x equals 10. Dividing both sides by 6 and reducing, we have x equals 5/3. Let's do another one. Example 2. Solve 4x over 3 plus 7 minus 2x over 5 equals 2. Let's use the same strategy. We have a fractional equation, so we want to find the least common multiple of the denominators. What's the smallest number that 3 and 5 go into? That's going to be 15. Therefore, we're going to multiply each numerator times the LCM. Multiply each numerator by the LCM. Okay, so we've preserved equality. We're multiplying every single term by the same number. All right, here we go, guys. First term over here, denominator 3 goes into 15. How many times? That would be 5 times. And multiply 5 times 4x for 20x. Next up, look at your denominator, 5. Does it go into 15? It should, because we designed it this way, right? 5 is a factor of 15. It goes in 3 times. All right, now multiply that through. 3 times 7, 21. 3 times a negative 2x, it's negative 6x. Okay, and over here on the right, we didn't have a denominator, so nothing cancels. It's just 2 times the LCM 15 for 30. All right, guys, we have to gather our like terms on the left before we start moving things to the other side. So that's going to be 14x plus 21 equals 30. And let's isolate our x term now by subtracting the constant. So add the opposite, leaving us with 14x on the left equals 9 on the right. Last step here, divide by the coefficient of x. And we have x equals 9/14. All right. We're always going to leave our answer as a reduced fraction. So you don't need to turn it into a mixed number if the case works out that way. You do not need to turn it into a decimal. X equals 9/14. Let's transition to some geometry now. Example 3, find x and y. So let's talk about this. These are called overlapping triangles. Overlapping triangles. Okay, and we're gonna fill this in. Overlapping triangles are blank. Let's see what they are. Overlapping triangles. Do you guys see two triangles here? You see this top one here? This top one here, the 2 by 3 by 4. You see that little one? Okay, cool. I was hoping so. All right, do you see the big triangle? The big triangle has that long side, this long side, and this long side. Okay, so as long as you see those two triangles, let's get rid of this. Okay, it is important that we draw these separately. Overlapping triangles are always going to share, they're going to share a common angle. So notice, if I give you this drawing here on the left, notice that these red angles are marked, so those are given. What you also need to recognize, even if it's not marked, is that this top vertex is shared by both of the triangles. So I've redrawn them separately. I drew the little one, I drew the big one. Okay, I put in those red angles that are given. Okay, and then I'm going to put these blue angles in. That is the same angle, comes from the same place. They overlap. And then once I see this, I remember a lesson a couple days ago that said that if two angles are congruent, then what's true? What is true about the third angle? Okay, that means that the third angle is also congruent, which means, let's mark that, we have 3 congruent angles. What does that mean? Overlapping triangles are similar. So cool. Now that you know you have similar triangles, you can match up the corresponding sides and find the missing variables. All right, but caution, don't get too excited because you have to be careful as you label the lengths of the sides. All right, so this top triangle, the small one, that's pretty easy. So that's labeled 2 by 3 by 4. Okay, but now we need to be careful. That left side of the large triangle, what is that? This 3 and the 2, those are the measurements of the little pieces that they're next to. Okay, so we have to add those together. We've got a piece that's 2 and a piece that's 3 long. Okay, so add those up for 5. And then over here on the right, what are we going to do about that? We've got a piece that's a length of 3, and this little piece here that's a length of x. So please don't tell me that's 3x. It's not 3 times x. We're adding the pieces together. So it's going to be 3 plus x. Okay, and then y is y. So as long as you took your time, you're super careful in labeling those long sides, you should be good to go. And we know that we have triangle similarity. And so we're going to be careful and match up all of our corresponding sides. All right, so you don't have to necessarily use the box. Okay, you could just write your ratios out, making sure that everything, all your numerators come from the same triangle and all your denominators come from the same triangle. And the corresponding sides match up with their opposite angles. Okay, the opposite angles should be equal. Okay, so we're ready to solve for x. So here's our x. It's in the denominator of that second term. What you're going to do is you're going to go get that proportion with the ratio that you know. Okay, you know 2/5, so you've got a proportion there. Go ahead and cross multiply. So 2 times 3 plus x for the first one, and then multiply the other way. 5 times 3 is 15. And that's how we're going to match up, that's how we're going to set up to find x. All right, let me get rid of this red box here. How are we going to set up to find y? we're going to set up y. Let's find our y. There it is. So we need to go get the ratio that we know, okay? And that you can kind of just ignore this one in the middle. Now do your cross multiplying this way. So 2y equals 5 times 4 for 20. All right, let's finish this up and multiply across. So we've got to distribute 2 times 3, 6. 2 times x, 2x equals 15. Okay, and subtract 6 from each side, which gives us 9. So x equals 9 halves after dividing both sides by 2. And over here, let's find y. It looks like we just need to divide both sides by 2. For y equals 20 divided by 2, or 10. All right, so that's how we solve for missing variables in overlapping triangles.